from YUMIN Primary School.
My name is Guo Cheng Guang, 8 years old, primary teacher, also from YUMIN Primary School.
Okay, so for this lesson is
Calculus.
Chapter 5, Indefinite Integration.
We will solve these 4 questions and
I will solve the first question and the third question.
okay, and no more making
What making?
questions, but next time we'll continue.
Okay, so for this, we'll start with the first question, which is integral dx over 1 plus cosine x. For this question, we cannot integrate immediately.
Yep.
So for this, here is actually an integral 1 over 1 plus cosine x. Remember the identity that we use a lot?
Yep. And let me write it down.
Yes, and for this, because that we
need to get.
Okay, so here we already have this 1 of the cosine, right?
Yep.
So what is the sine square x? So actually you just need to move the cosine square x to the other side, which is a 1 minus cosine square x.
And remember the a square.
Minus b squared, right?
Right.
So that is actually
A minus b times a plus b.
yes, correct. And remember, this is actually the a plus b. So now we need a a minus b.
And it will make up this thing. Let's make up this thing.
So for this will actually be a 1, right?
Right.
But we don't simplify it, okay?
Yep.
So then for this, these two can times together. Am I right?
Right.
So here we have the 1 minus cosine x over sine square x. And here is the dx. Right?
Right.
Right now we can split or separate. Like this, is it correct?
Yep.
So first for this, we can also separate again, right?
Yep. Okay.
So for this, the sine will actually can be a cosecant, right?
Yes. Because cosine will be a secant.
So we can change this like this, right? And remember, it should be a 1 over sine and a 1 over cosine, right?
Right.
So cosecant square x, what What can we change it to?
We can change it to...
So first for this cosecant, remember the thing? It is actually a negative cotangent, right?
Yes.
So this negative cotangent x, then you have this minus this integral. There's just a sine square x. So you can write it as a sine to the power of negative 2x d sine x. Then you
Yes.
plus the c prime, right?
Right.
Then here, right now we can integrate.
Yep.
So for this is actually a sine to the power of negative 1, which we can write it as a
Cosecant.
this cosecant x, and here there's a negative, right?
Yep.
So here's a plus.
So negative, negative, positive, and write it properly. Properly.
Like this.
Yep.
Can we have something actually?
What did
But I want to tell you, actually you can comment it on later, right?
No. No need.
Okay, so in this case you don't need, right?
Yeah.
So we can just move on to the next question, right?
Okay. And then the answer, remember.
Okay.
Okay, read out the question.
The second question is integral dx over 1 plus sine x. So for this, it's about the same way, right?
Yep. And write down what cosine square x equals.
So right now, we can times these together.
Yes.
So that will become that is a yes. So right now we can separate.
From
Sir.
answer is a cosine.
Okay. So like this. Then here we can separate again
Yep.
to become two of these integration, right?
Yes. So that cosine will be a secant, right?
Yeah. then that will need to minus. And please write bigger. So if there is a tangent x, so that will plus. Remember, this sine x tries to come in. Is that right? Calm down.
Underground.
So for this tangent x remains the same. Then now you need to integrate this part. Okay, so for that, but remember, this is a negative 1. When you differentiate, there will be another negative, and here you will need a positive. Why so small? Okay, much better. And also remember, 1 over cosine could actually change into
Secant.
Sure, that's the answer.
Yeah.
Very good. Okay, so next, on to the third question.
Okay.
So for this, the third question is integral 3 plus 2 cosine x, and this 3 plus 2 cosine x whole thing over bracket 2 plus 3 cosine x bracket square, and at the end we have the dx.
Yes.
So for this, it's around the same method, but what is the difference? We times a different thing.
Yep.
But actually now, for this question, remember here cosine, you can change it to the cotangent just by dividing it by a sine, right?
Yep.
And remember, if you divide a sine down here, what happens to the one above?
The above one also need to divide.
Yes. And remember, because this is actually a square, so here we can put it like this. Is it okay like this?
Okay.
And remember, for this, because down here there's the sine. So how many x?
It's sine x 2.
Sine square x.
Square. Not 2.
So over here for this, 3 plus plus this thing, we also need to avoid the sine square x, right?
Yep.
But just remember, we also can separate. So that will become like this.
Okay.
So down here we also separate, right?
Yes.
And remember for this, when we separate, here we have the integral 1 over. So here is the bracket. So this, first is the 2 over sine x.
Okay.
1 over sine x is a cosecant.
Yep.
So 2 over sine x is a 2 cosecant. Am I right?
Yes.
Okay, so for this, then we get plus. What is cosine over sine?
Cosine over sine is cotangent.
Yes, so here we have a 3 cotangent bracket square. Am I right?
Yep.
Then here, we try to put this in. But when we put it in, what will it become? Let's see, okay?
Okay.
So let me just work it out over here.
Okay.
So like this. Then first, we can separate, right?
Okay.
And remember, this will become a 3. Sine is a, this 1 over sine is a cosecant. So this is a 3 cosecant square x plus. So over here, we have this 2, but this cosine x over sine square x, what will we write it as? Can we just write it like this?
Oh.
Oops. But because here I didn't have the bracket,
Okay.
so here I can put like this, and then I can plus this back.
Okay.
But remember, in this case, this cosine x can actually try to go into the dx, right?
Yep.
So here, go in, becomes sine x, right?
Yep.
And also remember, this is a, what is this? This, because here's a sine x, so you need to write it as a sine to the power of -2 bracket x.
Yep.
So first, for this, what is cosecant square x dx? Cosecant, and remember you have the integral. But first, what if we don't look at the 3?
Okay.
3 stays the same, right?
Yes, cotangent.
But, are you missing something?
Negative. Because cosecant is negative cotangent.
Then, over here, we can have the sine, because it is to the power of -2, so we can have to the power of -1, which
Yes.
is cosecant x, right?
Yeah.
So this 2, what happens? Stays
2.
here.
Yep.
And remember, because of this, you need a positive here, and here's actually a negative. Like this, is it correct?
Okay.
Oh, I realized something. You know what is that?
What?
-3 cotangent x. Wait a second. You didn't realize a mistake here.
Oh. X.
because that both are negative, so we can have a negative to come out. Am I right?
Yes.
And also that constant, it actually can be a zero. It can be actually any number.
Yeah.
Right?
Yeah, there you
Okay, we can have a negative out.
Okay.
Out.
Out of the window.
Like this.
Yep.
So like this. Here we have this negative, this thing. Because that these two are the same. So we can put it like this.
Yep.
What is this? To the power of negative 3?
Okay.
So here, because that here's a negative and here's already to the power of a negative number. So in front here we don't have anything, right?
Okay.
But to make it seems more perfect, we can common denominator. Can we?
Okay.
So for this, what is the common denominator?
The common denominator. Okay.
And remember, because that is to the power of negative 1, reciprocal.
Yep. Reciprocal. Like this.
Like this.
Yep.
So this is the final answer. Okay? Everyone clear?
Yep.
Okay,
But
so
not
next.
yet the end.
On to the fourth question. The last but not least.
Why not, please?
Okay, the fourth question, please write it bigger.
Okay,
It is
and read out the question.
It is integral 2 plus 3 sine square root x over square root x bracket 3 plus 2 sine square root x bracket square. And don't forget the x. So for this, is it about the same method?
Yep.
If it says the same method, okay, let me test you. Why is there the square root x here?
The same method except for one.
Okay, let me tell you why. This is an x.
Square root x. Square root x.
So we need to put this square root x in here.
To make it the same.
Yeah.
And plus you need this to be a 2.
Remember when we found this?
Yep.
We found this and realized that it is actually the same, right?
Yep.
So for that, this part, what would you write? And please write bigger.
Okay, so
Bigger. So for this here at the numerator, what do you think can happen? Well, actually, in this first step, okay, so you just want to put this square x back here, right? Sine. Write the x properly. What about the bracket square? Faster.
okay.
So in this case, because this is a sine, so below, you need to put a cosine. Cosine what? Yes, cosine square root x. So up here, you also divide the same thing, right?
So since here the square go out, so here need the square. Wait, over here.
So that will be our cosine square root x. So then for this, we can separate.
Yep. But you can't separate the square. Enough, you can't solve it. Right?
Of course, if you put in the square, which means you expand, and you are unable to solve it. So quickly, and why is the integral so small again? Quickly. So this you will also separate.
Right.
And please faster. Wait, I have a question for you. Why is it a square?
Later than square.
Okay, so guys, when you continue, remember, here, this is a 2. Well, you actually can write something here. So for this 2 over this thing, it is actually a 2 secant square root x, right? So you'll just take this part, the numerator, and this, integrate.
Okay.
And also remember, this sine square root x over this cosine square root x is actually a tangent square root x. So for this 2 over this thing is actually a 2 secant square root x. Dx so for this, the first part, you can integrate. Wait a second, why is it a 2 over? Secant square root x d square root x, this integration is just a tangent square root x. There's no over.
Okay.
You still have a d square root x.
So this will be...
Okay, so let me just tell you, sine square root x will first go in there.
Yep.
But remember, because that cosine, there will be a negative. So here you need a... Yes, negative. Let me ask you, still square root x? Why do you have an extra square? Remember, this is just 1. So for this, but remember this is to the power of negative 2, so we have to the power of negative 1.
Yep.
So which is a secant? Remember it's a square root x. Then you have the... Okay, so like that. Then what about here? You can continue with here, right?
Okay.
So down here, you can just change this, right?
Okay.
So for this, 3, this over cosine square root x is then this is actually a tangent square root x. So then for this, remember this is a negative 2, so what you need is a negative 1, right? So negative 1, yes, there will be a negative there. So here you need to break out this thing. Write your 3 properly. Like that, you have to the power of negative 1. Then you have to plus the arbitrary constant.
Okay.
So then for this, to make it look better, common denominator. So this can be, negative common denominator, please. These two common denominator.
And those cancel out.
So this you have the 3 plus tangent. What's above? The sine, right?
Yep.
Yeah. Then below, which is the cosine square root x, comes above. And where is your negative 2? Okay, yes. Then what's missing? Okay, yes, are you sure that that's the answer?
Okay.
Okay, very good. So these are the answer for question 3 and 4.
Okay.
Like this, okay? So can we continue in the next lesson?
Okay.
Okay.
Bye.